So the question again is from the assignment number 3. And this question number 4, okay. It's also based on the same principle that we looked at. Okay. Where we have what? The source inductance, okay. All right, so let us look at what we are given. So it's a 3-phase, of course, fully controlled converter, okay. It's fed from a 3-phase 400 volts 50 hertz supply for a given firing angle of 60 degrees. So the output current is leveled at 25 amp and output voltage is 250 volts. Calculate the load resistance, source inductance, and angle of overlap. I think this is very, very straightforward, right? You know, we are just going to do the same thing that we looked at, okay? So we are given the supply voltage, right? So we are given the supply voltage. Let me just list everything that is given. So we're given the supply voltage, right? So the supply voltage or VI or VS, which is RMS, of course, this is 400 volts. We are also given the frequency. The frequency is 50 hertz, okay? We are also given the firing angle, which is alpha. So alpha is 60 degrees. We're given the output current, which is a DC current. This is a DC current output, right? Okay, ID or IO is just equal to 25 amps. We are also given the output voltage, which is the output voltage, V or VD, which is 250 volts. Of course, we know this is a 3-phase, okay? It's a 3-phase. So the question, okay, so I'll call this part A, or find the load resistance, right? Okay. So how do you get the load resistance? Since we know the current, okay? So the load resistance will be just equal to the output voltage divided by the current, right? So this case, we have the output voltage, okay? The output voltage is simply 250. The current is simply 25 amps. So this is 10 ohms, right? Okay. And then part 2, we have to find the source inductance. So how do we calculate the source inductance? So remember that if for this one, then we have to use what? We have to use the equation, right? Okay, so remember that the output voltage for a 3-phase having a source inductance is gained by what? 3 Vm. Okay, you can either use this equation F over pi, because this equation is the one that contains source inductance, right? Cosine alpha minus 3 ls omega, okay, times id, isn't it? And then divide by pi. Okay. Now we are given everything here. Okay, so just substitute. The output voltage is simply 250 volts. The VM is simply 2 times the RMS voltage. So we're given the RMS voltage of 400. Okay, divided by pi. The firing angle is given, which is 60 degrees. Minus, so we're looking for LS. Okay, omega simply 2 pi f. So our frequency given is 50 hertz. And then ID is 25 amps. Divided by pi. So you see that this pi and this pi of these guys always cancel out. Okay, so just like before, we can rearrange this. Okay, so let's first simplify this part here. Okay, so what is the product of 3 times 2 times 50 by 25? So this is 7,500, and I'm going to move this term to the left-hand side of the equation. So end up with 7,500 LS okay? And then here I have this guy, cos 60 times 400 times root 2 times 3. So cos 60 is simply half, right? So half by 200, you can do that math, which is what? Half by 400, so it's 200, 200 by 3, that's 600, right? So I have 600 root 2 over pi minus 250, right? So because this 250 has to be taken this side. Okay, so 600 root 2 over pi minus 250. Okay, so I have 7,500 it is. So this is about 20.094895, right? Okay, and if you divide by 7,500, okay, so that answer divided by 7,500. So this is about 0.002679 Henry. Or I can just say about it, 2.679 millihenry. So that is our source inductance. Okay. And then lastly, we need to find what? We have to find the overlap angle. Okay. So how do we find the overlap angle? Just like we did it before. Let's calculate the overlap angle. The overlap angle, we can now use the equation here. Okay. So because this equation is one that you use to find the overlap angle, which is the 3Vm over 2 pi. Okay. Cosine alpha plus cosine mu plus alpha plus mu, right? Okay, so let us substitute everything. So we know this is 250. This is 3 by the square of 2 by 400 divided by 2 pi, and then cosine 60 plus cosine 60 plus mu. Okay. Then let us simplify this, of course, just like before, of course, cosine 60. I will do the cross multiplication here by sending this to the other side of the equation. Okay, so I'll start by writing this cosine 60 plus mu. This is equal to 250 by 2 pi divided by 3 times the square root of 2 times 400. Okay, so let us simplify that. So cosine 60 is simply 0.5, right? Okay, so cosine 60 is simply 0.5. And then cosine 60 plus mu equal to, so 250 times 2 pi divided by 3 by root 2 times what? 400. So this side I'm getting is 0.925 okay? And then I'm going to subtract 0.5. So if I take this 0.5 this side of the equation, what do you have? So we're going to have 0.925 minus 0.5. So this is 0.4256, something like that, okay? And then take the cosine inverse, okay? So cosine inverse of this guy, okay? So take cosine inverse of both sides. Remember that cosine inverse of this just remain with that. Cosine inverse of this guy, what do you get? So cosine inverse of that guy, which is about 64, I think, 64.811. And then this side just remain with what? 60 plus mu. Okay. So mu will be equal to 64.811 minus 60. So you see that mu will just be equal to 4.811. Okay, just 4.81 degrees. So this is an overlap angle. Okay, any question? Hello, are you there?
Right. No question.
Okay, no question, right? So we're just remaining with one more question. Let's see. Okay, so let us see what we can do with this one. So I think the only meeting is about few minutes. Let's just log out. We'll come back again. Okay, before this session cuts. It's quite inconveniencing. When are you paying for the shan? For the limited room?